Well, hey y'all. Welcome back. It's been a while since we've done something like this, but maybe it hasn't. Maybe it just depends on when in time you're watching this video. Maybe you just watched another video yesterday and you're like, what are you talking about? It's been a while. But it has been a while since I put one on. And obviously you can maybe even tell from my voice, just getting over a little sickness. We're just in some different things, but we're back today and we are talking about products of whole numbers and fractions. So really, like, what a better way to celebrate. Obviously, as always, I like to break down what these words mean so we can make sense of it, right? So we're going to be talking about products today. So when we're talking about products, the easiest way for us to look at that is that's the answer when you're using multiplication, right? So that's the answer to a multiplication problem. So when I say something like 3 times 5, my product is 15. That's the product. So check. We're going to be doing some multiplication and finding an answer. Here we're talking about whole numbers. So if I am a whole number, remember that just means I have all of it. And those are just, whatever, like 1, 3, 12, 132. Wow. Is that a whole number the way you wrote that? um, 5,143. Whole numbers. They're just whole numbers. It's all of it. It's the complete. There isn't any left over. I guess what might help understand whole numbers better is like what isn't a whole number. Something like 3 and 2/10 is not a whole number because this is that extra bit. The 3 is a whole number, but this is 2/10, and that's extra put onto it. It's like a part of it. We don't need that. Well, I shouldn't say that. We need them. It's just when we're talking about whole numbers. Same thing here. This is not a whole number. 1 and 4/10, right? It's one whole number and then 4/10 of another number, so it's not the whole thing. So that's what makes a whole number. And then we're talking about fractions. So fractions actually are that part of a whole. Oh boy, this board. Fractions, part of a whole. So fractions are part of a whole, meaning again, I can take, oh boy, I'm already like having to move to the next page. I'll just put it right here. I could take something that represents a whole, right? So in this case, maybe I'm going to represent the number 1. Again, a whole can be anything. It could be 32. That's a whole because, again, it's a whole number. A whole could be a triangle if I'm drawing a picture, right? But the fraction is like the way that we cut it up in the parts of it. So like, again, if I took this number 1 and I cut it into 3 parts, right? 1, 2, 3. Well, now I'm at 3. And then I maybe shade in this piece. Well, that represents 1/3 of the whole, like this part right here, right? So yeah, I have the model is of a whole, but actually the only reality of it is I have 1/3. Or like maybe this is 1/3, or sorry, one whole movie theater, but people are only sitting in these rows, so only 1/3 of the movie theater is filled. And that's that fraction, right? It's a part of something. So wow. What a screen. That's what we're going to be talking about today. So like that example again is like what would happen if we took 4, right? That's a whole number. Whole number. And again, we're working with products. So what would happen if we multiplied that 4 and maybe we multiplied it by 2/3? That would be the fraction. And then when doing this work, wow, that does say fraction. When doing this work, our ultimate goal is, what is the product? How do we find it? So that's what we're going to look into. So a great example, 4 times 2/3. Well, before we even get into that, and I'm going to try to like go through this. Oh, I'll just do it down here real quick. Before we get into that, let's go back and understand what we know about multiplication, right? If we, I'm just going to say like 4 times 2 in this case. If we look at something like 4 times 2 in the beginning days of your multiplication skills, you first started learning that is like, oh, well, this is 4 groups of, right? That's of 2, meaning again, if I had 1, 2, 3, 4 groups, and those groups were of 2, there was 2 in each group. Well, then we would end up with 4 times 2 being 1, 2, 3, 4, 5, 6, 7, 8. And that's how we first started doing our multiplication. And then we graduated to that. We were like, oh, well, I don't have to draw these circles and these stars in these groups, because what I know is that this is one group of 2 plus another group of 2 plus another group of 2 plus another group of 2. And that also gets me 8. Again, 4 times 2 is 4. 1, 2, 3, 4 groups of 2. 2, 2, 2, 2, 2. Right? So that gets us 8. So knowing that, that's actually the approach we're going to put into this multiplication of whole numbers and fractions. So I'm going to go to this page and rewrite. So we have 4 times 2/3. So if we think about that concept, this is telling me right now that I have 4 groups, and each group is 2/3. I have 4 groups of 2/3. So I'm going to just start and actually model that. I'm going to go ahead and I'm going to go with 1, 2, 3, 4. And I'm going to cut those right into thirds, right? I have 4 groups, so bear with me as I do that real quick. And I'm going to shade in 2/3 of each one. So this says 2/3. And this says 2/3. And this says 2/3. And this says 2/3, right? So if we were to think about that, 4 groups of 2/3, just like we kind of thought about these like 4 groups of 2, right? We know that we're really just putting all this stuff together. So let's actually put that together. I'm gonna actually do that math. What I'm gonna do is I'm gonna take this third and I'm gonna put it over here. So I'm gonna go ahead and should we shade first? Let's shade first. So I'm gonna move that over. So this third I shade in right here. And excuse me. And then we're gonna get rid of it because we just moved it over. Then meaning that this is no longer 2/3. This is actually 3/3. And then we're gonna go ahead and take this third and I don't know, put it over here, right? So I'm gonna go ahead and take this and erase that, because now, in a sense, this doesn't exist anymore. Right? This model itself is kind of gone. Ooh, that got confusing. I won't do that. It's just empty. And then this right here, should have caught that. Thank you. Became 3/3. And so then if we look at what we have when we put this together, well, this is a whole and this is a whole. So that's 2 wholes. And then I have 2/3. So 2 and 2/3. So that's one way we can look at this. It's like when we put these together, we're able to actually make sense of what we get out of it. Now, that's modeling it. That's the way to show it. That's a visualization, and that's an answer. That works. Actually, 4 times 2/3 is 2 and 2/3. So let's look at another example with this. But this time, instead of thinking about just drawing all the models and moving things over, let's look at it in this concept of repeated addition. So let's see here. Why don't we take 8 times 3/4? So again, when we think about this, what it's literally telling me is that I have 8 groups of 3/4, which means I have 1 3/4, 2 3/4, 3 3/4, 4 4/4, 5 4/4, 6 4/4, 7 4/4, and 8 3/4. Sorry, I think I said 4/4 at some point. I was getting really confused counting and saying fractions, but that's okay, because see, that's what I've done. I've taken and I've made 8 of these, right? And then we know then we're just putting these together. So this is like that repeated addition concept. 3/4, 3/4, 3/4, 3/4, 3/4, 3/4, 3/4, 3/4. Now we're just adding fractions. And you know what? We know how to add fractions. We've done all that work. In fact, we always ask that first question. Are they compatible, right? Are all the denominators the same? Absolutely. So if they're all the same, that means I still have fourths. Next, we're going to add all those numerators. So that would be 3, 6, 9, 12, 15, 18, 21, 24. So that would get me 24. So I am now looking at that 8 times 3/4 equals 24/4. But we also know that this is that improper fraction. So now I'm going to do that other step. This is why I love it when we get to this math, because it's like we start to see all the things we've learned before this and why they're so handy. As a top-heavy fraction, again, it's just a division problem. That's 24 divided by 4. Oh, and that's actually just, wow, that comes right out as a whole number, doesn't it? 24 divided by 4 is 6, because 6 times 4. So yeah, when we take 8 times 3/4, we just get 6. It works out. But you can see why, right? And again, instead of drawing 8 3/4 models and shading and moving things over like we did here, it was a little more efficient actually in this case with 8 to just go 3/4 plus 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 3/4, which got me 24/4, which really is just 6, because 24 divided by 4 equals 6. So that's that. So that's that piece. Now, let's take it to the next, because maybe we're already seeing a pattern, right? Maybe we're seeing something that if I was skip counting here, maybe there is actually a pattern I could have been doing instead of drawing all these out, because sometimes this is really helpful. And obviously, a lot of times in a word problem, we're going to be asked to show it. So we can't just write the answer, but we got to show how we got there, draw some models, do some repeated addition. But let's just say, you know, all of a sudden I got to figure out 500 times 2/5. Well, I'm not going to sit here and draw 500 models, shade them and move them around. For the same exact reason, I'm not going to write 2/5 plus 2/5 plus 2/5 plus 2/5 100 times. I'm not going to do that either, or 400 times even. Like, there's no purpose in doing that. But if you kind of look over here and you see kind of what's happening, even in repeated addition, it is multiplication. Now, we know with fractions, the denominator will stay the same when we add them. And we know we only have one denominator. That's not going to change. And so really, we are looking at the idea that we're taking this whole number and we're multiplying it by this numerator right here, right? So that actually shows right here is something I could do then. There's this third way I can do this. I can say, oh, you know what? I'm going to take 500 and I'm going to multiply it by 2, right? Because I have 500 groups and in each group there's 2. So that's going to give me 1,000. Did I do that right? Dang. Over 5, right? Because again, we know they're all 5s. And then from there, look at this. We got this crazy top-heavy fraction, which again, actually, this is going to be a whole number again. So that's interesting, because sometimes when we multiply, we get fractions, and sometimes when we multiply, we get whole numbers out of it. So let's go ahead and see what that is. That's 1,000 divided by 5. Oh, this is base 10. I was going to like do a big, but this is base 10, because look, 10 divided by 5 equals 2, and then do my laundry, right? This 0 does not have a match, so I give it as a match. This 0 does not have a match, so I give it a match. And so this actually equals 200. Why did I pick 500? I don't know. But there you have it. This is actually the work we can do. We have all sorts of things. And I'm going to sum this up super fast and call it a day, because think about this. We could model them all and then, like, I don't know, kind of move the shading around. And that's what we did here, right? We modeled it and then we moved things around. And that's great. I love that idea. That would work. We also have another strategy in which we could do that repeated addition, which totally works as well. I love that. Big fan. Thanks for coming. And then we look at something like this. Oh, sorry. And that was this idea. I should show that. That's a repeated addition. And that's what we did here. All that craziness. And then in this case, when we have numbers that are so big, really, we realize that we have a strategy or a pattern. Maybe I'll just call it a pattern for now, in which we can multiply. So think about those. Think about when they apply. Maybe even challenge yourself to try problems in all 3 ways, just thinking about when would you use what strategy, because I do feel like this is really accurate. So when you're working with smaller numbers, that would be great. And then you're not making mistakes because you really can see the fractions. This is a great one as well. Just at what point do you think about not writing them all out because you have so many? And this is great too, but also keep in mind that with this really does require that we're accurate with our multiplication and our division, because we are going to always end up with a top-heavy fraction, I think, in this case. Therefore needing to do a little division work to get it back to a mixed number and or a whole number. So that's it. I'm done. That's all I got. I like it. Feels like a good video. So thank you. Ask questions, do hard work, be awesome. You're great, and we'll talk to you later.